Bismillah ar-Rahman ar-Rahim. We have seen economic order quantity model, and one of the assumption was that the instantaneous receipt was there. That when we place an order and when the order is received, it's received in single batch. Now, sometimes there is a production run going on, that the production is going on, and at the same time the demand is there, which means that we built the inventory. At the same time, there is a demand going on, and such a model is called a production run model. So we will see this assumption here now. When inventory accumulates over time, the instantaneous receipt assumption does not apply. So we are relaxing that assumption which was in basic EOQ model. We are saying that no, there is no instantaneous receipt, but rather the built up of inventory is there, uniformly built up, uniformly accumulation of inventory is there. The daily demand rate must be taken into account, because at the same time when we are building the inventory, the demand is also there. So the demand is also met. The revised model is often called the production run model. So if we can see over here from the figure, we start building the inventory, we start the production run, and why it is going like that? Because there is no instantaneous here. We are building the inventory, at the same time there is also we are meeting the demand. Now at certain level, when the inventory level reaches to a certain level, we just stop the production run and let the demand take over, and we stop the production. And then after some times, when the inventory is depleted, we start another production run. So this is a production run model. In production run, setup cost is replacing the ordering cost. Now what is setup cost? This is the cost of setting up the production facility to manufacture the desired product. It normally includes the salaries and wages of employees who are responsible for setting up the equipment, engineering and design costs of making the setup, paperwork, supplies, utilities, etc. So these are the costs involved. So what we will do is we will replace the ordering cost with setup cost. And we are using another symbol here. Instead of C0, we are using CS here. Q is the same as number of pieces per order or production run in this case. And CH is the holding or carrying cost per unit per year. Now we have another variable added over here, which is the daily production rate. P is equal to daily production rate. D is the daily demand rate. We have seen this earlier. This is another we have added T in the model, another symbol. T is equal to length of the production run in days. So if I go back, previous, T is over here is the production run time or production cycle. So the maximum inventory level is the total produced during the production run minus the total consumed during the production run. Okay, that will be the maximum inventory level. If you see over here, if I go back again to that figure, we have the maximum inventory over here is this, which is that PT is the production per day multiplied by the T is the time minus DT. DT is the demand per day into the time T. So this will be the maximum inventory. All right. Let's look at that. So here we have the daily production rate into number of days of production minus the daily demand into number of days of production. We have PT minus DT is the maximum inventory level. The total produced is Q is equal to P into T. P is the production multiplied by the total cycle of the production. So we have Q is equal to P into T, and from here we can also say T is equal to Q over P. And in the maximum inventory level, PT minus DT, we just replace T with Q over P, and finally what we get is this one. Maximum inventory level is equal to Q into 1 minus D over P. Now, since the average inventory is 1/2 the maximum, so the average inventory will become Q by 2 into 1 minus D over P. Okay, so maximum inventory divided by 2. Maximum inventory is Q 1 minus D over P, and then average inventory is just divided by 2. And annual holding cost is Q over 2 into 1 minus D over P into CH, because this is our average inventory multiplied by the holding cost per unit per year. Regarding annual setup cost, we have the same as similar to annual ordering cost. Annual ordering cost was D over Q into C naught, where D over Q is the number of orders multiplied by C naught. Here D over Q means number of setups multiplied by the setup cost per setup. So this is annual setup cost D over Q into CS. Again, the same theory that the minimum occurs when annual holding cost is equal to annual setup cost. So we equate these two, and then we find Q optimal, and what we found is this is our Q optimal, which is very similar to Q EOQ model, which we have seen earlier. EOQ model, which is 2D C naught over CH square root. As you can see over here, now C naught is replaced with CS here, and CH with some other term has come 1 minus of D over P. Now if you see over here that if P is very large, P is large and D is small, okay, D is approaching to, let's say, 0, and this is approaching to infinity, then this becomes 0 or almost 0. Then what we can say is that this model is the same as instantaneous model. Okay, only difference is 1 minus D over P. If P is large and D is small, then the model reduces to the same as instantaneous receipt model. These are the equations, summary of equations: annual holding cost, annual setup cost, and then the optimal order production quantity, Q optimal. Let's see an example again. Brown Manufacturing produces commercial refrigeration units in batches. The annual demand is 10,000 units. Setup cost is $100 per setup, and carrying cost is CH is equal to $0.5 per unit per year, and daily production rate is equal to 80 units daily, and daily demand rate is 60 units daily. Then we can just apply our model. We have Q naught is equal to 2 DCS over CH into 1 minus D over P, and just plug in those values. What we get is the optimal quantity 4,000 units, and the production cycle will be Q over P. T is equal to Q over P, right? So this is the 50 days will be the production going on, and then we are left with some few days for just the daily demand will take over, and we stop the production, and then another cycle will start. Using Excel, we just have plotted these holding costs and setup costs and the total cost, and of course we can see that where the minimum is occurring is about 4,000 units. Now we come to the quantity discount models. Remember that in EOQ model, the basic model, inventory model of economic order quantity, we assume that there were no discount. Now again we are assuming, we are relaxing that assumption, and we are saying that yes, there are quantity discounts available. Now how to take into account that? The basic EOQ model is adjusted by adding the purchase or material cost. Now before that, in EOQ model we said the only cost relevant which were variable were ordering cost and holding cost. But now the material cost is no more constant, because we are getting discounts for ordering more. So we will now have to take into account all these costs. So total cost is now D into C. D is the annual demand multiplied by the C is the purchase price or the cost of item, plus D over Q into C naught, plus this is the ordering cost, this is the holding cost, and this is the cost of the material. So total cost is all these three costs. Now because unit cost is now variable, so we will use holding cost instead of CH. It is some percentage of the item cost. So we have I is the holding cost as a percentage of the unit cost. So we will just replace CH with IC here. All right. Let's see a typical discount schedule here. We have three schedules. We have discount number 1, where there is actually no discount, 0% discount is there. If we order less than 1,000 units, let's say less than 1,000 pieces, the cost is assumed that $5 per unit is there. If we order between 1,000 to less than 2,000, then we will get 4% discount, and this means that our price will be, or the cost will be in this case, is $4.8 per unit. And if we order more than 2,000 pieces, then 5% discount is there, and we will be paying $4.75 per unit. Now from looking at only this schedule, we cannot say that buying at the lowest unit cost is not always the best choice. Why? Because we have the two other costs, which are ordering cost and the holding cost. So we have to see as a whole. So if we plot this total cost curves for discounts, for discount 1 and discount 2 and for discount 3, we will see that we will get something like that. Now you can look at economic order quantity for discount 2 is less than 1,000 batches, let's say, coming here, but we will not get the discount unless we order minimum 1000 units. And the same goes for schedule number 3, that if we order 2000 units pieces minimum, then we will have this discount 3, this curve will be there. So it means that we have to at least order 2000 units. Now let's look at this how we calculate these 3 costs. Now we take the example of a brass department store example, which is stocking toy race cars. Their supplier has given them the quantity discount schedule shown in table 6.3. So we have seen the earlier table, which there was no discount if it is less than 1000 units, and it was $5 per piece. And then we have a 4% discount for in between 1000 units and less than 2000 units. And then we have another discount if we order more than 2000 units. So that schedule is there, which is we have seen in the previous table. And let's say the annual demand is 5000 cars. These are toy cars, and ordering cost is $49 per order, and holding cost is 20% of the cost of the car. Then the first step is to compute the EOQ values for each discount. So we have EOQ1, which is we are using the cost as $5 per piece. So I is 20% of the the item cost. So we just use this. We find that EOQ is economic order quantity is 700 cars per order. If we use the schedule number 2 cost, which is $4.8, we get 714 cars per order. And if we use 4.75, the third schedule, which is 5% discount, then $4.75 is the item cost. And what we get is economic order quantity we get is 718 cars per order. Now you can see that if we order 700 cars per order, that's fine. But if we order for second schedule to qualify for this price 4.8, the economic order quantity is actually 714, but they will not give us discount because it is less than 1000 units. Similarly, for having discount of 25 cents, which is 4.75 is the price of the unit, then we will have the economic order quantity is 718, but this will not be qualified unless it is more than 2000 pieces or 2000 or more pieces. So what we have is we just work out the minimum quantity first at which we can order. Q1 is 700. This is EOQ also, EOQ1. We can order this and we can see what is the total cost coming. For Q2 we will set to the minimum, okay, and for Q3 also we will set to the minimum to qualify for $4.8 price or cost of the item, and here we will $4.75 for the cost of the item. Okay, if we buy 2000 units or above. So we will put it at the minimum. Q2 is put at 1000 and Q3 at 2000. We will forget about 714. sorry. Okay. We will forget about 714. When this become heated up, then it gives little problem. Okay, it's giving problem again. Let me go back. Okay. All right. Yeah. So we calculate actually the total cost, which is the summation of these three costs: annual material cost, annual ordering cost, and annual carrying cost. This is the total cost of these three choices. What we have is first the order quantity 700, then we will look at the order quantity 1000, and then order quantity 2000. We will forget about the economic order quantity at 4.8 because this was not qualified, which was coming 714, and this one I think was coming 718. So we will forget about that, and we will put it the minimum level at which we qualify for these prices or this cost. So we have 1000 here order quantity, and here we put 2000, and then we calculate these all these costs here. So we have the D into C, total demand, annual demand multiplied by the C is the price of the or the cost of the item. So what we have is 25,000 here, 24,000, etc. Annual ordering cost is G over Q into C naught, and then annual carrying cost is Q over 2 into CH. When we add all these three costs, what we can see is what is the minimum, and the minimum is coming is the fourth step is to choose the alternative with the lowest total cost. So in nutshell, what we have is 4-step summary. Calculate the Q star or economic order quantity for each discount price. If Q star is too small to qualify for that price, adjust Q optimal upward to the lowest possible quantity that qualifies. That's what we did. And again, because it has become heated, okay, and then we calculate the total cost for each Q optimal. Okay, we have adjusted Q optimal for those where we cannot qualify at the minimum level, and then calculated the total cost for each Q and select the Q optimal with the lowest total cost. These are the 4-step summaries involved to get the minimum quantity to order. So in this case, what we will be ordering is 1000 units. This is shown in what we call it Excel, and you can see over here that the minimum cost over here is then 1000 units, where we can order 1000 pieces to qualify for this $4.8 price. We stop it here and then we will continue.